Hey there, students. We are now going to look at an example to help illustrate how to perform hypothesis tests using StatCrunch. And the logic of a hypothesis test is challenging for many students, and so we'll be using a problem where they actually want us to draw a conclusion or state a conclusion based on the results of the hypothesis test, and hopefully that will help illustrate the logic that we have to use to understand how a hypothesis test works and what conclusions we can draw from using one. So let's look at this problem. This is number 32 on the exercise number 10, homework number 10, from 8.2. It says, suppose that in a random selection of 100 colored candies, 20% of them are blue. The candy company claims that the percentage of blue candies is equal to 25%. Use a 5% significance level to test the claim. So clearly you didn't get 25%, and so the idea of the company's claim is that they're not claiming that every time you get candy from them you get exactly 25%, because there is some randomization when the candies are mixed together and put into a bag or when a sample is taken. And so instead what they're saying is that that on average that would be what you get, sort of that the mean value, or that the proportion in general for the entire population is 25%. So therefore when you take samples like bags of candies from that the mean value would be 25%. So maybe you think, well, I think they're a little low on that. I think maybe they're not actually doing what they said. So we want to test the claim that the candy percentage is equal to 25% at the 5% level. So this is a test of equality for a proportion. We're not testing whether it's bigger than a number. We're not testing whether it's less than a number. We're testing whether it's equal to a number. And so this is the situation in a hypothesis test where the null hypothesis is actually the same as the claim. If the claim is about being equal to a value, since the null hypothesis is always set with equality, then the null hypothesis is the claim itself. So in this case, the claim is that it's equal to 25%. And so that means our null hypothesis should be that P, the proportion of the population, is equal to 25%. We can see that's the case in A, C, and D here. So then the alternate, when your original claim is that it's equal, and that is the claim you're testing, then the alternate to that is simply that it's not equal. If your claim was greater than or less than a number, then equality would be your null and your claim would be the alternate, greater than or less than. But if your claim is equal to a number, then your claim is the null and the alternate is always then just that it's not equal. So for us, P equal 0.25 and the alternate being P not equal 0.25 is C. So then they ask us to identify the test statistic. Again, what does that mean? That would be the distribution score you get from your sample, based on your sample. And since this is a proportion hypothesis test, the distribution will be a z distribution, so the test statistic should be a z-stat. All right, so I have StatCrunch open here, so we can put this null hypothesis into StatCrunch and use it to see what the test statistic is. So I would go to Stat, and this is a claim about proportions, so I go to Proportion Stats, one sample, and in this case they gave us a summary. So there were 100 colored candies in our random selection, and 20% of them were blue. Now they want the number of successes, but luckily in this case that's an easy calculation. 20% of 100 is 20. And then the hypothesis test is as we labeled here in part A, is that P is equal to 0.25 or not equal for the alternate to 0.25. And so once we've entered that in, then StatCrunch will do the work for us. So as I described, a proportion distribution will be a z distribution, and so the test statistic is the z-stat, and they want that to 2 decimals, so I'm going to grab this for 2 decimal places. Looks like I don't have to round up. Then they also want the p-value. So now we are starting to try to understand p-values for hypothesis test. The p-value is the probability that you would get the sample that you got, assuming the null hypothesis is true. So in this case, we have a p-value given by StatCrunch of close to 25%. And so the meaning behind that, which I think we'll have to use in part D, we can just put the value over there, just copy it over for part C. So I guess I'll just do that, round to 3 decimal places. All right, so that's the p-value. But what does the p-value mean? It means that there's a 25% chance that you would have gotten candies as far away from the 25% claim as 20% just by random chance, even if the actual population proportion really was 25%. So 25% likelihood of this occurring just by random chance is pretty common, but we compare that to our significance level of 5%. So the p-value would need to be below 5% for us to believe that our sample was good evidence that the null hypothesis was false. But since this is fairly not uncommon, I mean, it's not, I don't want to say likely, but it's not hard to get this level of difference from 25% by random chance, it's not really sufficient evidence to reject the claim that the candy company made, that the percentage is equal to 25%. So ultimately, the thing you'll start to remember is that if the p is low, the null must go, meaning if the p is below the significance level, then you reject the null hypothesis. But if not, as in this case, if the p is not low enough, then we fail to reject the null hypothesis. Move my little window up here. And so fail to reject the null is offered in B and C here. And if you're rejecting the null, that means you did not have sufficient evidence to reject it. That's why you failed to reject it. So that's B. Failed to reject the null hypothesis. There is not sufficient evidence to warrant the rejection of the claim that the percentage of blue candies is 25% as made by the company. And so that's the logic. So I know that's a challenge. It really takes us a while to understand this logic, but at least StatCrunch does the heavy lifting of the calculations for us, and then we just have to think about the results and how to interpret them. Keep up the hard work. See you when I see you.